Hello. In this video, I'll try to explain Newton's three main laws of motion as simply as possible. Newton's first law of motion states if a body at rest is moving at a constant speed in a straight line, it will remain at speed or keep moving in a straight line at a constant speed unless it's acted on upon a force. You can see this law of motion wherever you look. Relative to Earth, most objects around you are sitting still. They can't move unless you try to move them. But to do that, you have to exert a force on said object. In another example, let's look at an object in space. Since space doesn't have any active forces, if you move something, it could move towards that direction forever. Here on Earth, that doesn't happen because of gravity and friction. Newton's second law of motion states that the time of change of the momentum of a body is equal in both magnitude and direction. The moment imposed on the momentum of the body is equal to the product of its mass and velocity. Newton's second law of motion states that the time of change velocity is a vector quality having both magnitude and direction. A force applied to a body can change the magnitude on its direction. To summarize, to calculate a force, you have to find the object's mass and acceleration, multiply them together, and you find its force. To go back to the earlier examples, the objects around you are currently still, since while they do have mass, they don't have acceleration. If I do move something though, that acceleration increases, leading to the object having a force. While here on Earth, forces like gravity and friction usually stop the movement of an object, in space, there's an indiscriminate amount of gravity and friction, so the object keeps moving forward, but since the acceleration doesn't change, the force is still zero. Newton's third law of motion states when two bodies interact, they apply forces to one another that are equal in magnitude and opposite in direction. This means whenever you push on an object, the object pushes back at an equal yet opposite direction. Back to those previous examples, the objects around you are currently being held up by a table, a chair, or the floor. While the floor keeps these objects up, the objects are also pushing down on the floor, or the table, or the chair at an equal yet opposite amount. One thing about Newton's laws is that they work everywhere, even in space. For example, if an object in space wanted to move, like let's say a spacecraft, it would exhaust gas or pressurized air and move in the opposite direction at an equal force. These are all three of Newton's laws. I hope you enjoyed the video. Goodbye.